This busy construction site is giving Barcelona Football Club's stadium the ultimate facelift. Once finished, this massive redevelopment will raise the capacity to 105,000 seats, making it the largest football club stadium on the planet. This unique transformation is an extraordinary engineering challenge. The new stadium is being built without destroying the club's original and much loved ground-level stands from the 1950s. Overseeing this complex process is Director of Operations Juan Santellas.
No Barcelona fan could ever imagine the stadium being somewhere other than in Les Corts. This is our home, this is where our heart is, and this is where Barcelona Football Club's stadium should be.
The first step was to reveal the 1950s architecture by removing the 1980s extension that sits around it. Specialized machines, resembling mechanical dinosaurs, carefully nibbled away the later additions, leaving the original core untouched. Next, engineers built a freestanding ring of steel around the old stadium to carry the weight of the new development. This avoids any unnecessary strain on the stadium's original 75-year-old foundations. The new third tier will hold 30,000 spectators. A lightweight roof will cover every seat, sheltering fans from the blazing Barcelona sun. And 18,000 square meters of solar panels will help make the stadium both sustainable and spectacular. The new cleverly engineered third tier is designed as a cantilever, so it will appear to float above the old stadium. The external ring of steel also bears the weight of the roof. The stadium's new framework is inspired by 1930s New York skyscrapers. To erect it, workers use prefabricated steel beams, manufactured to precise tolerances that simply bolt together. A layer of concrete then adds extra strength and stability. This rapid assembly technique allows the 3,500-strong team to construct around 600 tons of steel in a week.
To give you an idea, the Eiffel Tower weighs 7,000 tons. In 2.5 months, we built an Eiffel Tower.
Remarkably, much of the raw building materials have been recycled from the demolition of the old stands. 97% of the old steel will be reused in the new construction, lowering the carbon footprint of the new design, as well as incorporating elements of its past. With the finish line in sight and hopes of welcoming fans even before construction is fully complete, Barcelona's new stadium is set to captivate audiences across Europe and beyond. Spanish engineers have not only constructed epic architectural wonders, but also spearheaded the invention of cutting-edge machines. For centuries, the nation's innovators have found groundbreaking ways to traverse Spain's rugged landscape. In 1907, engineers constructed Spain's first ever cable car on Mount Ulia near San Sebastian, while Spanish engineer Juan de la Cierva built the world's first autogyro, the precursor to the helicopter. In the Basque region, engineers are using innovative machines to create an ambitious new high-speed rail line, linking Vitoria, Bilbao and San Sebastian through the Pyrenees Mountains. The Basque Country, located in the Western Pyrenees, has rugged, mountainous terrain. This creates a major challenge for the engineers building the new railway here. The track's viaducts need to be extremely tall to span vast chasms. It's not practical to construct them using traditional techniques, with cranes hauling their concrete sections into place block by block. So engineers use remarkable machines that cast the bridge sections in situ, from liquid concrete poured up to 100 meters in the air. Javier Selvas Arsuaga is in charge of building a key section of this high-speed line, which includes the Arrazola Viaduct. It's a 1,755-meter-long overpass connecting the towns of Achonde and Abadiño.
I have worked on a lot of very important projects, but this project is very interesting. It is the longest viaduct on the entire line.
The innovative machines at the heart of the project are giant frames, known as movable scaffolding systems, that balance on top of the bridge columns. Their insides form a mold for the team to pour in liquid concrete. Once it's set, the machine opens to reveal the new bridge section. Then it moves along, ready for the next pour. Today is the big day to unveil the latest bridge section. But before they can open the mold, Javier must wait for the concrete to fully set. In the foothills of the Pyrenees, the crawling yellow movable scaffolding system is part of an army of machines building viaducts across the landscape. This red machine in a nearby valley is preparing for its next pour of concrete. First, it contracts to create a mold for a 66-meter section of the viaduct. Then, engineers carefully position a dense network of steel rods inside the mold to reinforce the strength of the viaduct. Next, they pour in the concrete to form the base, sides, and finally the deck of this massive structure. At the Arrazola Viaduct, the concrete is finally set, and it's time to open the machine. Powerful hydraulic pistons swing open the scaffold. Javier is now able to inspect the new section.
We want to make sure there are no fissures or large cracks before we continue to the next section.
The viaduct's undercarriage is too high to examine from the ground, so the team use a drone to get a better view.
I am happy because it turned out well.
Over the coming weeks, the Arrazola Viaduct will take shape and eventually join the largest high-speed rail network in Europe, with the lowest average construction cost. These mega machines are a game changer, speeding up construction and allowing engineers to lay over 50 meters of viaduct a week. Each completed section of high-speed rail track brings Spain closer together, strengthening bonds between the regions as well as neighboring countries, providing a major boost to the nation's economy.